and they can't tell you a simple definition of what the average is. The average is the number that represents no variation. If I was to give you a bar chart or a histogram, and I have to really think about this. Let's say this bar chart looks something like this. Okay, there's my bar chart. And I asked you what the definition of the mean is. You would say the definition of the mean is what? Well, the definition of the mean, what if you was to take this guy, I hope I drew it correctly. Take this guy and chop him off right here. And we'll take and hatch him up as x's. Yeah, I'd get mad and leave too. Just disgraceful. And we chop him off and put him right here. In other words, there's your x's.
You're very good at this.
Okay? So I take this guy and I chop him off right there. Why did I chop him off here? Because he's level with this guy. And then I take and chop this guy off and make him hatch marks and put him in this area. And I can take my red marker and I can draw a line where? Right there, can I? And that number right here represents the mean. So now you can tell me what the definition of the mean is. It's the number that represents no what?
Variance.
No variance, no variation, nothing. In other words, it's the magic number that levels the what? Playing field. It's the number that represents no variation, or very little, or levels the playing field. I don't know how to spell field. I always get I and E mixed up. And yeah, I before E except after blah blah blah, but I can't remember that. So anyway, so that number right there represents no variation. So you've got the mean that represents no variation, and then you've got the standard deviation that tells you how much variation what you have in the data. So you've got to learn to read this stuff. And I guarantee you that somebody in here, well, nobody in here knew the definition of the mean. But you knew how to find it on a calculator. But you didn't know what it was. So you missed it. Oh well.
I'll watch the video.
Okay. The mean is the number that represents no variation or levels playing field. In other words, it takes these guys, I'll show it to you right quick, Ms. Black. This guy fills in for this guy, and this guy fills in for this guy. And it levels your data. So, going back to the previous page, here our number that represents no variation is, what was our mean? 21, somewhere around there? I can't see that number, hold on. 21. So the number that represents no variation with this data is 21. This standard deviation is 4, so that means that we do have variation in the problem due to what? At 28. This one tells us that our standard deviation, the level playing field, is at what? 21. But our standard deviation is 3. It's a little bit less because of the variation between these two numbers is less than the variation between the 21 and the 28, or whatever it was. If you was to take out this number and put a 22 here, it would do a lot, wouldn't it? Watch what it does. Can you predict what it's going to do? Somebody tell me what they predict it's going to do.
That standard deviation is going to go down.
Would you say it's going to go down less than 3?
No, it would be about the same as the other one.
22. Why wasn't it 3? The other one was 3.
The numbers are smaller.
Look, what's the mean now? 20, right? What's that number? 22. So your gap between your mean and your highest number is a whole lot what? Lower than the one down here. The mean down here is 20, but what's the number down there? 25, right? So you got a difference of 5 and a difference of what? 2. Your variation is not spread out as much. So your variance is going to be, your standard deviation is going to be tighter. These are the things that you've got to think of when you're doing statistics. You don't just do statistics, punch it in a calculator like any monkey or my 7-year-old and say, okay, the variance and standard deviation is this. And then when a teacher asks you what is the standard deviation, you go, I don't know. You ever felt like that before? So, what do you do if you open it up to the whole class? Now, in the last class, we had 26 people. And I didn't keep it so that you can watch that video. We had 26 people, and it came out to be really tight data. We only had, I think there was a 34-year-old, she sat right here, and a 28-year-old sat right there. Neither one of them looked like a day over 20. Okay? But they threw, and then when I threw mine in there, we just threw it all out at once. Just made it, the standard deviation was like 106. All right? So, we're going to do all of y'all. So, you throw out any number you want to, but make sure if you're a woman, you can throw out any number you want to. If you're a man, no, you cannot. All right, Miss Black, you said 25, right?
Mm-hmm.
All right, next. You said 24 or 20, what'd you say?
24.
24. We're going this way. Huh?
21.
21.
19.
19.
19.
19.
18.
18. Oops. 18.
29.
29.
20.
20.
19.
19. 18.
19.
19.
18.
18. And we're going to put those in order. Daniel will go data. Daniel will be sending. There you go. And we're going to call them X. And what is N? Well, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So N is equal to 12. And let's go ahead and find our summation. That's that. And mean is equal to this number divided by that number. And median is N even or odd? even, so that means we gotta count, let's see, 5 up and 5 down, right? 5 up, 1, 2, 3, 4, 5, and there's our two numbers, which are what?
19.
I'll give y'all a hint. The average of 19 and 19 is
19.
19. But I'm gonna go ahead and put the formula in here, just in case they change. You need to put the formula in there. This number plus this number, there's always some smart aleck. I have to say that first part because there's always some smart aleck. Why don't you just put 19? Yeah, you're so smart. I got 2 degrees and I didn't even know that. Divided by 2. The reason you put it is these two numbers are not always going to be what? The same. So you put the formula in there so it will calculate it. And see, I'm thinking, okay, this is 12, so up here I got 5 and 6. So what should you be putting between 6 and 12? 7, 8, 9, 10, 11. And that way, save it, and you'll have it for the test or for your homework. And you just punch the numbers in. Okay? Unless you just want to do it the difficult way, and that's by hand and using a calculator, because I think it's a whole lot more difficult to use a calculator, but that's just me. Okay, so now I'm going to take this little mode, let's do the mode and all that trash. Mode is equal to, I have no idea, 18 has 3, 19 has 4, 19?
Yep.
Let me ask you something, mean and the median. Oops, media, that's not right. Are they close?
Yes.
Yes. So that tells you that your data is what? Pretty close together, pretty tight. Range. Range is really not worth anything, but they asked for it, so equals your highest minus your what? Minus the lowest. And mid-range is equal to parentheses highest plus the lowest divided by 2. And now do the variance. Well, we got to go ahead and do x minus x bar and x minus x bar quantity squared. This minus this and F4 and copy. And then take that number and do what with it? Square it, Hubert. That's right, class. And the variance is equal to this number divided by this number minus what? Minus 1, Hubert. That's right, class. Appreciate the interaction. And then what do you do to get the standard deviation from the variance? 0.5 power, good. Now look at the standard deviation. So we went from a 4.3 to a 3.0 or 3.1 back up to 3.5. Now why did our variance, why did the standard deviation go up?
Because of the 29.
The 29. 29 kind of didn't mess us up. It just opened up the gap between that last number and the range. Whereas before, right here, what's the gap between the last number and the highest?
1.
That's why I dropped down. That's why. Now if you throw a 48 in there, I kind of throw the slop in there. Dang old 48, dang old half century. Dang old dirt. add a 68 in there. Change the standard deviation. And the standard deviation is telling you, okay, you're reading this data, what am I telling you? You're telling me that there's a lot of variance in there. But if you take that 68, move it down to 26. Changes the standard deviation down to below 3. Now, also look at the mean and the median. That's a good indicator. These two numbers right here are close together. That means your data is pretty tight. If you throw a 48 back in there, are they tight? No. Throw a 68 in there, are they tight? No. Throw a 24 or 25 back in there, that's pretty tight. Interpreting, calculating, obtaining, calculating, and interpreting. That's what statistics is. Statistics is not punching in a calculator, writing down a number, and not having any earthly clue what you just wrote down. That's not what statistics is. Aprende? All right, let's do a nerd. Let's do one out of your homework. Say again?
We do.
Pretty sure class is over.
We were trying to keep this long.
Is class over?
It's over.
What time's class over?
11.
It's 10:58. It ain't over yet. Heck, come. I'll go ahead and call the roll because y'all about to go into cardio and park. So let me call the roll.
That should be understandable.
Somebody hit my panel. Would you hit my button up there? Where the thumb goes? Thank you, man.